Hello everyone, myself I am Dr. Lakshmi Soujanya, working as an associate professor in the Department of Mathematics from Marri Reddy Institute of Technology and Management. In the previous session, we learned how to find the rank of a matrix using echelon form. So in echelon form, we focused on the upper triangular matrix. To convert the given matrix to echelon form, we focus on upper triangular matrix. Now today we'll discuss about the normal form. It is also used to find the rank of a matrix. So we are having either we can call normal form as also canonical form. We have four types of normal forms: IR, identity matrix of order R, or a row vector IR0, or a matrix notation IR00, or a column vector IR0. These four types of forms are called as a canonical form or a normal form. So if you have any m by n matrix, to find the rank of matrix, first you have to convert that matrix to any one of these four canonical forms: IR, identity matrix of order R, or matrix notation IR00, row vector IR0, or column vector IR0. So to convert the matrix, given matrix to any one of these four forms, here I'll follow three steps. I'll focus on three steps. As you all are comfortable with echelon form, so you take step 1 as upper triangular matrix. Half of the solution. How we have done in echelon form, you do the same solution for normal form also. First you convert the given matrix to upper triangular matrix form. Then in step 2, you convert the matrix to lower triangular. Then in step 3, you focus on the canonical form, identity matrix form. So you have to complete the solution in 3 steps. In step 1, you have to convert the matrix to upper triangular. In step 2, you have to convert the matrix to lower triangular. Then in step 3, you convert the matrix to identity form. So once you got identity form, then definitely you will get any one of these 4 forms of canonical form. Then once you got canonical form, you can define the rank of the matrix as the order of the identity matrix in the canonical form. See, in all these 4 canonical forms, we have some order. Here the identity matrix order is R, here also R, here also R, here also R. So we can say that R is the rank of the matrix. So how we can define the rank of matrix? The rank of a matrix is the order of the identity matrix in the canonical form. So to find the rank of a matrix using canonical form or normal form, first you have to do 3 steps: upper triangular, lower triangular, and then identity matrix. Then you can choose the rank of matrix as the order of the identity matrix form. So let us see one problem. Here I am taking one problem. We have to reduce the 4 by 4 matrix to normal form and find its rank. So I have taken one 4 by 4 matrix. First you take the matrix. Your given matrix is -1, 2, 3, -2, 2, -5, 1, 2, 3, -8, 5, 2, 5, -12, -1, 6. So this is a 4 by 4 matrix. So first you have to reduce this matrix to canonical form. What are the canonical forms? The canonical forms are either identity matrix of order R, or a row vector form IR0, or a matrix notation IR00, or a column vector form IR0. So to convert this matrix to any one of these 4 forms, you have to do the solution in 3 steps. Step 1, upper triangular. So first you have to convert this matrix to upper triangular. That means you have to convert all the lower diagonal values to 0. All these values to 0. I think you know how we have converted the given matrix to upper triangular form in echelon form. To complete the solution in less number of steps, I told you that you do the solution, you complete the step. In each step, you try to complete the values which are in one column. At a time, you convert the values which are in single column to 0. That means here, first I focus on the values which are in the first column. I'll convert the values 2, 3, 5 to 0 in the first step. So that means which rows we are changing here? R2, R3, R4. So the row operations are R4, R2, R3 and R4. Now how we can change these values? We are not changing one row. By using that row only, we can change these 3 row values. So which row we are not using? We are not changing R1. See, in R2, here I have 2. the corresponding value in R1 is minus 1. Instead of minus 1, there if you are getting 2, by adding both the rows, you will get 0. That means we can change R2 as R2 plus 2R1. Next, for R3, here the value is 3. The corresponding value in R1 is minus 1. So, what is the row operation? R3 plus 3R1. Now, so what is the row operation? R3 gives rise to R3 plus 3R1. Now, you have to change R4. For R4, here I have 5. Here if you get 5, then 5 minus 5, you will get 0. That means the row operation is R4 plus 5R1. Now, what about the values? We are not changing first row. Your first row is minus 1, 2, 3, minus 2. Here I am doing the row calculation part. So, what is the first row? We are changing second row as R2 plus 2R1. So, first write on R2. R2 is 2, minus 5, 1, 2. 2R1. Multiply the first row with 2. Then minus 2 into 2 is 2 minus 2. 2 2s are 4. 2 3s are 6. Again minus 2 into 2 is minus 4. By adding both the rows, you will get 0. Minus 5 plus 4 is minus 1. 1 plus 6 is 7. 2 minus 4 is minus 2. Next, for R3, the row operation is R3 plus 3R1. So, first write on R3. R3 is 3, minus 8, 5, 2, 3R1. Now, multiply the first row with 3. So, minus 3, 3 2s are 6, 3 3s are 9, minus 6. By adding both the rows, you will get 0. Minus 8 plus 6 is minus 2. 5 plus 9 is 14. 2 minus 6 is minus 4. Next, for R4, the row operation is R4 plus R1. So, first write on R4. R4 is 5, minus 12, minus 1, 6, 4R1. Now, multiply the first row with 4. That is 5R1. So, multiply the first row with 5. So, that is minus 5. 5 2s are 10. 5 3s are 15. Minus 2 into 5 is minus 10. Again, by adding, you will get 0. Minus 12 plus 10 is minus 2. Minus 1 plus 15 is 14. 6 minus 10 is minus 4. So, first you represent the lower diagonal values. In lower diagonal values, see, at a time we converted the values which are in the first column to 0. Now, in the next step, you focus on the values which are in the second column. So, the values which are in the second column are minus 2, minus 2. So, you have to convert these two values to 0. Which row we can use here? We are not changing R1 and R2, but here you have to choose the row which is similar to R3 and R4. So, the row which is similar to R3 and R4 is R2 only. So, by using R2 only, you can change R3 and R4. So, the corresponding value in R2 for minus 2 and minus 2 is minus 1. So, here instead of minus 1, if you get 2, by subtracting both the rows, definitely you will get 0. That means the row operations are, we are changing R3, R4. We are changing R3 and R4. How we are changing R3? By using R2 only, you have to change R3. That means the row operation is R3 minus 2R2. Similarly, for R4 is also R4 minus 2R2. Now, write down the matrix. So, in this step, we are not changing first two rows. So, first two rows are minus 1, 2, 3, minus 2. Next 0, minus 1, 7, minus 2. Now, write down the row operations. So, the row operation for R3 is R3 minus 2R2. First, write down R3. R3 is 0, minus 2, 14, minus 4. Similarly, the R4 is also same value. So, do the calculation 2R2. R2, so multiply the second row with 2. You will get 0, minus 2, 14, minus 4. Now, by subtracting both rows have same values. So, by subtracting, you will get 2 0 rows. Since R4 is also minus 2, 14, minus 4, there also you will get 0 row. So, now represent the lower diagonal values. See here, all the lower diagonal values are converted to 0. That means we got upper triangular matrix. So, with this, your first step is completed. Now, in step 2, you have to focus on lower triangular. Lower triangular means you have to convert all the above diagonal values to 0. So, here above diagonal values are 2, 3, minus 2, 7, minus 2, 0. So how we have done calculation for upper triangular, you go with the same procedure for lower triangular also. But instead of row, you have to go with column operations. Instead of column, you have to focus on row operations. That means in upper triangular form, here we are changing rows R2, R3, R4. How we are changing R2 in a single step? I'll focus on your values which are in single column. Now for lower triangular, you have to change columns like C2, C3, C4, C5, and this step you have to focus on the values which are in row. I hope you are understanding. So here you have to remember two things. To get the upper triangular matrix, what we are doing, we are changing rows, and in a step we are focusing on the values which are in the column. At a time we are converting the values which are in the column to 0. Now for lower triangular, you have to change columns and you have to focus on the values which are in a single row. So that means in this step, see, you have to change columns and you have to focus on the values which are in a single row. So first I'll focus on the values which are in the first row. At a time, I'll convert 2, 3, minus 2 to 0. That means which columns we are changing? C2, C3, C4. So you have to take column operations for C2, C3, C4. By using which column we can change these three columns? By using C1 only. We are not changing C1. So by using C1 only, you can change C2, C3, C4. And what is the column operation for C2? Here I have 2 and the corresponding value in C1 is minus 1. Instead of minus 1, if you got minus 2, by adding both columns you will get 0. That means the column operation is C2 plus 2 C1. Similarly in C3 I have 3. So we need 3 in C1, that is C3 plus 3 C1. Next for C4, here I have minus 2. So we need 2 in C1. So C4 minus 2 C1. That means what is our matrix? Now column wise you write down the value. Since we are changing column wise, your presentation is also column wise only. We are not changing first column. So first write down your first column, that is minus 1, 0, 0, 0. Next C2 plus C1. We are changing C2 by using the column operation as C2 plus C1. So first write down C2. C2 is 2, minus 1, 0, 0. 2C1. Multiply the first column with 2, then you will get minus 2, 0, 0, 0. So by adding both the columns, you will get 0. Here it is minus 1, 0 plus 0, 0 plus 0 is 0 only. Next, how we are changing C3? C3 is C3 plus 3C1. So first write down C3. C3 is 3, 7, 0, 0. 3C1. Multiply the first column with 3, you will get minus 3, 0, 0, 0. So by adding both the columns, 3 minus 3, 0, 7 plus 0, 7, 0, 0. Next for C4, we are taking the column operation as C4 minus 2 C1. So C4 is minus 2, 0, 0. 2 C1 means minus 2, 0, 0, 0. Now subtract both the columns. Minus 2 minus of minus 2 is plus 2, that is 0. Minus 2 minus 0, minus 2, 0, 0. So again represent above diagonal values. So these are your above diagonal values. Still we have 2 more values. See, in this step, at a time we converted the values which are in the first row. Now in the next step, you have to focus on the values which are in the second row. So the values which are in the second row are 7 minus 2. So which columns we have to change? C3, C4. So the column operations for C3 and C4. How we have to change C3? Here I have 7. The corresponding row column is C2. How we have done for row? The same operations you have to take here also. You have to choose the column which is similar to C3, C4. So the column which is similar to C3, C4 is C2 only. So in C2 the corresponding value is minus 1. Instead of minus 1, here if you got minus 7, then minus 7 plus 7 is 0. That means your column operation is C3 plus 7 C2. Next for C4, here I have minus 2. If you got minus 2 in C2, then you will get, by subtracting both the columns, you will get 0. That means the column operation is C4 minus C2. Now write down the matrix. We are not changing first 2 columns. First 2 columns are minus 1, 0, 0, 0, 0, minus 1, 0, 0. Next. So how we have to change C3? C3 we are changing as C3 plus 7 C2. So first write down C3. C3 is 0, 7, 0, 0, 7 C2. Multiply the second column with 7. Then this is 0, minus 7, 0, 0. So by adding both the columns, you will get 0. 7 minus 7, that is again 0. 0 plus 0 is 0. 0 plus 0, 0. Next for C4, the column operation is C4 minus 2 C2. So C4 is 0, minus 2, 0, 0, 2 C2. Multiply the second column with 2, that is 0, minus 2, 0, 0. By subtracting, both columns have same value. So by subtracting, you will get 0, 0, 0, 0. Now if you are taking upper diagonal, see all the upper diagonal values are 0 and similarly lower diagonal values are also 0. So we completed step 1, step 2. Now in step 3, you have to focus on identity matrix. Identity matrix means both below diagonal and above diagonal values are 0 and the diagonal values are must and should be 1. But see, here instead of 1, I have minus 1. That means if we have to get 1 here, instead of minus 1, we have to get 1. So what is the column operation? Either you can choose column or row operation here. I'll go with column operation. So instead of minus 1, I need 1 means you have to multiply the first column with minus sign. So C1 gives rise to minus C1. Similarly for C2 also, C2 gives rise to minus C2. Now what is our matrix? Your matrix is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So we got an identity matrix with all ones and lower diagonal above diagonal are 0. Now we completed step 3. So here to find the rank value, first you have to know the order of identity matrix. So for that you represent the final matrix to canonical form. That means any one of these 4 forms. So here to take these forms, what I will do is I will divide the matrix into subparts until the non-zero diagonal value. See, here we have 4 diagonal values. The non-zero diagonal value is at second column, second row. So I will divide the matrix up to second column and second row. Now represent this one into identity matrix canonical form. Your first part, first submatrix is a identity matrix of order 2 by 2. Next one, 0 matrix with 2 rows, 2 columns. So 0 of order 2 by 2. Next here again 0 matrix with 2 rows, 2 columns. And next one is also similar to like this, 2 by 2. So that means for this question, we got identity matrix of this form, IR 0, 0, 0, matrix notation. So now using canonical form, how we can define the rank of the matrix? The rank of matrix is the order of identity matrix. What is the order of identity matrix here? 2. That means the rank for this matrix equal to 2. So for canonical form, we can define the rank of matrix as order of identity matrix. So here the identity matrix order is 2. So your rank is equal to 2. This is our answer. So is it clear how we have to convert the given matrix to canonical form and how we have to define the rank of the matrix? Let us see another problem. So here I will take another problem using canonical form. Find the rank of. Here also I am taking 4 by 4 matrix only. So take 4 by 4 matrix. Your given matrix is 1, 2, minus 1, 3, 4, 1, 2, 1, 3, minus 1, 1, 2, 1, 2, 0, 1. So first, what is the first step to convert the matrix to canonical form? Your step 1 is upper triangular. So convert all the lower diagonal values to 0. What are your lower diagonal values? 4, 3, 1, minus 1, 2, 0. These are your lower diagonal values. So here in a single step, since I am changing rows for lower diagonal values, for converting matrix to upper triangular form, you have to change rows and in a step you have to focus on the values in a column. That means you have to change these 3 values 4, 3, 1, 2, 0. So which rows we have to change here? We have to change R2, R3, R1. So the row operations are R2, R3, R1, R4. By using which row we can change here? By using R1 only we can change R2, R3, R4. Here the corresponding value in R1 is 1. Here I have 4. In R1 if you got 4, then 4 minus 4 you will get 0. That means the row operation for R2 is R2 minus 4R1. Next for R3, here I have 3, here I have 1. So you need to get 3 in first row. That means row operation is R3 minus 3R1. Next for R4, here I have 1, here I have 1. So the row operation is R4 minus R1. Now what about the value? We are not changing first row. First row is 1, 2, minus 1, 3. Now you have to change R3. R3 is changed by using the row operation. We have to change R2. R2 is changed by using the row operation R2 minus 4R1. So first write down R2. R2 is 4, 1, 2, 1. Next 4R1. Multiply the first row with 4. That is 4. 4 2s are 8. Minus 4, 12. Now by subtracting you will get 0. 1 minus 8 is minus 7. 2 minus of minus 4 is plus 4. So 2 plus 4 is 6. 1 minus 12 is minus 11. Next R3 is changed as R3 minus 3R1. So R3 is 3 minus 1, 1, 2, 3R1. Multiply the first row with 3. 3, 3 2s are 6, minus 3, 9. Again by subtracting, this is 0. Minus 1 minus 6 is minus 7. 1 minus of minus 3 plus 3. So 4. 2 minus 9 is again minus 7. Next R4 minus R1. Here only I am doing the calculation. R4 minus R1, that is 1 minus 1 0. 2 minus 2 0. 0 minus of minus 1 plus 1. 1 minus 3 is minus 2. Now represent the below diagonal values. These are your below diagonal values. So in this step we converted the values which are in first column to 0. Now in the next step you have to focus on the values which are in the second column. See here already in R4 the value is 0. So you have to change only the value which is in R3. And which row we can use here? The row which is similar to R3 is R2 only. So the corresponding value in R2 is minus 7. In both the places you have minus 7. So by subtracting R2 and R3, definitely you will get R3 value as 0. That means the row operation is R3 gives rise to R3 minus R2. So now what about the value? We are not changing first two rows and fourth row also. First two rows are 1, 2, minus 1, 3, 0, minus 7, 6, minus 11. Now R3 minus R2 means 0 minus 0, 0. Minus 7 minus of minus plus 7. So that is also 0. 4 minus 6 is minus 2. Minus 7 minus of minus 11 is plus 11. Minus 7 plus 11 means that is 4. Next we are not changing R4. So write R4. R4 is 0, 0, 1 minus t. So now in all the lower diagonal values, still we have one more value in R4, that is 1 to 0. So we have to change R4 here. We have to change R4 and the row which is similar to R4 is 0, 0, 0, 0. So similar row for R4 is R3. So here in R3 I have minus 2. Here I have 1. Instead of 1, here if you are getting 2, by adding both the rows you will get 0. That means you have to multiply the fourth row with 2 and you have to add that row to R3. So now what about this value? This is 1, 2, minus 1, 3, 0, minus 7, 6, minus 11, 0, 0, minus 2, 4. Now how we are changing R4? What is the row operation? 2R4, that is 0, 0, 2, minus 4 plus R3. R3 is 0, 0, minus 2, 4. So by adding both the rows you will get 0, 0, 0, 0. So we converted all the lower diagonal values to 0. So upper triangular matrix is completed. Step 1 is completed. Now you have to convert the matrix to lower triangular. That means you have to convert all the above diagonal values to 0. So here above diagonal values are 2 minus 1, 3, 6 minus 11 and 4. You have to convert these values to 0. That means in the next step, since we are focusing on lower triangular, you have to change columns. Column wise you have to change the values and you have to focus on, in a step you have to focus on the values which are in one row. So first I will focus on the values which are in the first row. So which columns are existing here? C2, C3, C4. That means you have to change C2, C3, C4. How we can change C2? Here I have 2. The non-changing column is C1. By using C1 only we can change these 3 columns. And the corresponding value in C1 is 1. Here if you got 2, then 2 minus 2 is 0. That means C2 gives rise to C2 minus 2C1. Next here I have minus 1, here I have 1. So C3 is getting 0 as C3 plus C1. Next in C4, here I have 3, here I have 1. Instead of 1, if you are getting 3, 3 minus 3 you will get 0. That means row operation is C4 minus 3C1. So we are not changing first column. First column is 1, 0, 0, 0. C2 minus 2C1. What is C2? C2 is 2 minus 7, 0, 0. 2C1. Now multiply the first column with 2, 2, 0, 0. So by subtracting, this is 0 minus 7, 0, 0. Next, C3 plus C1. Just add first and third column. 1 minus 1, 0. Remaining all are 0 here. So 0 plus 6, 6. 0 minus 2, minus 2. 0 plus 0, 0. Next, C4 is C4 minus 3C1. So C4 is 3 minus 11, 4, 0. 3C1. Multiply the first column with 3. 3, 0, 0, 0. So by subtracting, 3 minus 3 is 0. Minus 11, 4, 0. So now, in all the above diagonal, we converted the values which are in first row to 0. So in the next step, you have to focus on the values which are in the second row, that is 6 minus 11. Which column we have to change here? 6 minus 11 means you have to change C3 and C4. Which column we can use? The column which is similar to C3 and C4 is C2. So by using C2 only, we can change C3 and C4. So the corresponding value in C2 is minus 7. Here I have 6. There is no common multiple between minus 7 and 6. So do the cross multiplication. That means you multiply the third column with 7 and second column with 6. So 7 C3 plus 6 C2. Similarly for C4 also, here I have minus 11, here I have minus 7. There is no common multiple. So do the cross multiplication. 7 C4 minus 11 C2. Now what about these values? We are not changing first column and second column. That is 1, 0, 0, 0, 0 minus 7, 0, 0, 7 C3. Now 7 C3 means multiply the third column with 7, that is 0, 7 6 is 42, 7 2 is 12, 0. Next 6 C2, multiply the second column with 6, 0, minus 42, 0, 0. So by adding both the columns, 0 plus 0, 0. 42 minus 42 is 0, minus 14 plus 0 is minus 14, this is 0. Next, 7C4. Now multiply this fourth column with 7, 0, 7 11s are 77, 7 4s are 28, 0. 11C2. Multiply the second column with 11, 0, minus 77, 0, 0. So by subtracting, this is 0, 0, 28 minus 0, 28, 0. Now see, in all the above diagonals, still we have one more column, 28 to 0. That means here you have to change C4. And the column which is similar to C4 is C3 only, 0, 0, 0, 0. So by using C3 only, you can change C4. So the column operation is C4 and here corresponding value 14. 14 2s are 28. That means you can multiply third column with 2. So C4 plus 2C3. Then you will get 1, 0, 0, 0. 0 minus 7, 0, 0, 0, 0 minus 14, 0. And by multiplying third column with 2, you will get 0, 0 minus 28, 0. Now add C4 and this one, 0, 0, 28 minus 28, 0, 0. So we got both upper triangular and lower triangular. Step 2 is also completed. Now you have to convert the matrix to identity matrix. That means all the diagonal values are 1. So now we have to convert all the diagonal values as 1 means, see the first row, first column is 1, but here I have minus 7, here I have minus 14. In those two places also you need to get 1. So either use row or column operations. So here I will go with row operations. So you have to divide the entire second row with minus 7. That means R2 gives rise to R2 by minus 7. Next, similarly for R3, you have to divide the total R3 with minus 14. So R3 gives rise to R3 by minus 14. Then you will get 1 0 0 0 1 0 0 0 0 1 0 0 0 0 0. So we got the identity matrix also. All the diagonal values are 1. Now you have to represent this to canonical form. So how we can represent the final matrix to canonical form? What you have to remember here, you have to subdivide the matrix up to which you have non-zero diagonal value. See, here I have non-zero diagonal value. This one is 0. So you have to divide the matrix up to third row, third column. Now represent this one. Third row is first submatrix is 1 0 0 0 1 0 0 0 1. This is an identity matrix of order 3 by 3, 3, I3. Next one is a column vector. I'll represent that column vector as 0 or capital O. And how many rows we have here? 3 rows, 1 column. So 3 rows by 1 column. Next one is a row vector. I have only 1 row with 1, 2, 3, 3 columns. So this is O with 1 row and 3 column. And next one is a normal element, so 0. So this is a canonical form. Now when using this canonical form, we can take rank as the order of the identity matrix in the canonical form. So here the order is 3, so rank is equal to 3. That's it. So is it clear how we have to convert the matrix to canonical form and how we have to choose the rank? What we have to do here to convert the matrix to canonical form, you go with 3 steps: upper triangular, lower triangular and identity matrix. Once you got identity matrix, then represent that identity matrix to canonical form and take rank of matrix as the order of the identity matrix. So with this, I'll complete normal form. In the next session, we'll discuss about the Gauss-Jordan method to find the inverse of a matrix. Thank you.